Okay, so what are we trying to find? The force on Q1. All right, so I'm going to draw a free body diagram here. So Q1 is here. Q2, those are both positive charges. So Q2 is going to try to push me back this way. That's F2 on 1. So that's, I can see immediately that that's going to look like some negative X value and 0 Y.
Right.
Because it's all horizontal. 3 on 1, that's a negative and a positive. So 3 is trying to attract 1. So 1 wants to go down. This will be F3 on 1. And
Okay.
again, I can see immediately that that's going to be some no X value at all and some negative Y value.
Okay. At least I drew it right with the free body.
Okay, and then nano means 10 to the negative 9th. So F21 in magnitude will be, I'm going to be more specific here, 8.99 times 10 to the 9th. That's K. And then 140 times 10 to the negative 9th. 2 is what I want. I don't care about positives or negatives here.
Right.
Why do they? I don't know. They should have put a negative there. I mean, it's in the picture. I'm going to edit this problem and make sure that that's clearly negative.
Okay.
This one's 185 times 10 to the negative 9th. And then what's our distance? 1/10 of a meter, so 0.1 squared. All right, so let me get my calculator open here. All right, clear. So 8.99 EE with this button right here, 9th times 140. Takes longer to type this out than it does to do most of the problem. 185 negative 9 divided by, was it 0.1 squared? Okay, so 0.023. So
Okay.
as a vector, we want to write this in vector form. F21 is negative, I forget what I said now.
0.023.
Was it 0? I literally just looked at it. 0.23, right?
Yeah.
And then 0 Y component.
Right.
Right. And then same thing. F3 on 1 in magnitude. Again, we never use negatives here. That's a common mistake. I look at the picture and tell that it's going to be negative.
Right.
Don't look at Q's and tell that it's negative. So 899. What was Q1? 140. 118. And then that distance was, I'm going to have to use Pythagorean. No, I don't. Because we're not going here to here.
Right.
Yeah, 0.3
Right.
squared. Okay, now, if I'm really careful in my calculator, I can just do second entry and just change what needs to be changed.
Right. Okay.
So this should be 118. And then the distance was 0.3. No, I changed the wrong one. Hold on. This one is 140. This one's 118. You got to be really careful doing that, though.
Right.
Okay, 0.001. I guess I'm going to 3 places here. Okay, so then F31, and I already figured out that 0x and a negative y. And then what's the final answer? Okay. And then to get F net, I add those together as vectors. I'm going to send this recording to everyone, so that's why I'm going through all the details here. So
Okay.
add the x's, add the y's, and then to find the magnitude, we use Pythagorean. So that'll be square root. Anytime you're doing Pythagorean, ignore the negatives, because when you
Okay,
square a
right.
negative, it disappears anyways. And I see a lot of people that will type this. They'll go like this. They'll be like square root of negative 0.023.
And it gives you like undefined.
Delete. Oh, 3. Where's my squared button? There it is. Squared. They'll type like that. And that's not what we want. I want that in parentheses. And the best way to do that is when you square a negative, it's going to disappear anyway. So don't even put the negatives in. 0.023 squared plus 0.001 squared. And plus 001, right? Wait, what was the answer? I didn't get the right answer.
Did we do something wrong? All right, so here I'm finding F2 on 1. 185. That distance was 0.1 squared. 3 on 1. I'll pause this recording. All right, so this one should have been 0.3. This one should have been 0.1. So those numbers were wrong. Okay, you know how to do it from here though, right? Yeah. So it should be right now. I felt like that's what I was doing before, but I guess not.
Okay, do you want me to go ahead and work it out and see if it's right?
I think I can do it. I mean, this one uses the Pythagorean because it's in a triangle,
Right,
but
because our final,
18 is a line.
right.
Okay. Interesting. Okay.
So 18. Now these might be different numbers than you have.
I have all negative. Yeah. I mean, it's all negative numbers.
Okay. Here, let me open up yours again. Okay, I'm gonna stop sharing for a second. I don't want to show you everybody else's grades. What was it, 18?
18 was one of them, yeah.
There you are. Okay. 13, 18. Okay, I'm sharing, you can see it.
Yes.
Okay, so B is negative. I need to draw this out. So we got A, B, and C. That's how they labeled them.
Yes.
0.3 and 0.5. We need to have these in meters. Did you do that?
Yes, I had 0.3 meters, but then I had 0.8 because,
Right, from A to C.
yeah,
Are we going to need that? What are we trying to find?
on A.
Yeah, on A. So yeah, we'll need that. So that's 0.3, and this will be 0.8 meters. Okay, so let's write down their charges. They're all three negative, 5, 5, and 3. So this guy was -5 microcoulombs, another -5, and -3. Is that correct?
Yes.
Okay, so F, B on A is going to point backwards because these two try to run from each other.
Right.
He's going to push him back. So this will be some negative X component and 0 Y. And same thing for C on A. Some negative X and 0 Y.
Okay.
So we just get these answers and we add them together and it'll point toward the left. It'll be some negative number.
Right.
So B on A will be 9. I'll just use the 9 times 10 to the 9th times 5 times 10 to the -6, another 5 times 10 to the -6 over the distance 0.3 squared. And that's magnitude. And then same thing for C, and then you literally just add those numbers together because they're all in the X direction.
And I would be adding the negative numbers at that point, not positive numbers.
What you're going to take care of the negative right here by saying to the left.
Okay, so it
So
would be
this is just
positive.
asking for the magnitude, which will be a positive number. And there's where you get to say it's negative by saying it's to the left.
Okay, I think I can do that. I guess I was just tripped up with the Pythagorean.
Yeah. Okay. You feel better?
Yeah, and 31, the last one. I feel like I followed the video almost exactly, but I don't know what I did wrong. Because it was kind of different, like it wasn't between the two, it was on the outside. So the distances threw me off, maybe.
Right. You got to be careful in how you draw it up. So let's put Q1 at the origin. Here's Q1. 2 is at 6 centimeters. So this is at I'll put it here, 0.6 meters. Oh, excuse me. Let's see, we got 6.1 and -2.1.
Is it 0.6 or 0.06? Did I do that wrong?
It's 6.1.
Or the distance? The X.
Oh, 0.06. I'm sorry.
Oh, okay.
0.06. Yeah, because it's centimeters. And then what was this guy? 2.1. Yeah, and he's negative. Okay, so this guy has an electric field that points away, but gets smaller as it gets further away. He has an electric field that points toward him, but gets smaller as it goes away. So there's no way it's in here because everything points to the right in here.
Right.
Over in this region, we're closer to him, so that makes this guy big, but he's a bigger charge, so that makes this guy big. The answer is going to be over here somewhere in this region.
It's over there?
Yeah,
Oh, I thought it was, oh,
right, because if you're over here, you're closer to the big one, so he's going to win on both counts.
oh, right.
Yeah, there's no way it could be here.
Okay.
Okay, so I'm going to call that D, and this whole distance from here to wherever it is, I'm going to call that D. Then my equations will be, because we're just setting the forces equal, we just want K, Q1, Q2, or what we're doing the electric field, right? Where the electric field is equal. K, Q1 over this whole distance I called D should equal K, Q2 over, now I just want this distance. That's going to be D minus 0.06.
Minus, oh, okay. I guess because I thought it was the other way, I put plus.
Yeah. Yeah, and that'll get it wrong. That's why you got to figure out the right spot
side.
first. Yeah. In this case, this doesn't always work, but in this case, because we know D is going to be a positive number. See, remember, if you take the square root of both sides, if I had x squared equals 4, if I take the square root of both sides, I'm supposed to put a plus or minus over here.
Mhm.
Because we know D is positive, we don't actually have to do that here. I can just take the square root of both sides and not worry about the plus or minus, because I know I'm only going to get one positive answer. And then that makes it a whole lot easier because the K's already canceled out. But now I can take the square root of D squared and just get D. And over here, square root of D minus 0.06 squared is just D minus 0.06. And now it's a
Oh.
linear equation. It's much easier to solve.
Oh.
I don't have to use quadratic formula.
That makes it a lot easier.
Uh-huh.
Okay.
Okay.
Interesting.
Does that all make sense?
Yes.
Okay, so there was a lot of good information in this. Are you okay if I post this
Oh, yeah,
in the
that's fine.
announcements? Okay, so like for anybody watching the video, I think I got this in the recording. I had my locations backwards. I had a 0.1 here and a 0.3 here originally. Those were backwards. These are the correct ones. And then Pythagorean once you get your final vector. Okay, any other questions?
Not at this time. You really cleared it up. Thank you.
All right, no problem. Have a good day.
You too. Bye.
Bye.